Thank you for coming this early Thursday morning. My name is Charlie Berger. I'm the Senior Director of Product Management for Oracle Machine Learning. And with me is Nipun Agarwal, the VP of Oracle Labs. We've struck up a nice partnership between labs and development where they invent some pretty cool new technologies. And then we deliver them to the marketplace as part of the Oracle Autonomous Database or the Oracle on-premise database, or essentially the Oracle database. We also have algorithms that run outside the database in what we call Oracle Machine Learning for Spark, but this is going to be Oracle Machine Learning database variety, if you will. We have about 45 minutes. I'll cover some overviews, some details about what we do for automated machine, basically what we do, then some details about, in machine learning in general, some details about automated versions or aspects of machine learning. I'll introduce some of our new features and functions. I'll turn it over to Nipun, and then I'll come back into the end and show you some new graphical user interface enhancements we're adding as well. So with that, the punchline, if you can only stay for 5 minutes, the punchline is that our development team, what we've decided to do from quite a while back is to move the algorithms to the data. Rather than moving the data, data gets to be large and you have to move it somewhere else to process it. And then if you do build a very good predictive model over here, how do you productionize that model? How do you take the model needs, the algorithm and the model you've built needs data to apply the model to new data, and the data is where? Oftentimes it's in an Oracle database. So we've made the strategic decision quite a while ago to teach the relational database how to do complex math. And so today you'll see how far that's come. We've had over 30-something algorithms inside the database, and now we're adding the AutoML, which really just sort of automates things even further. So that's the punchline, safe harbor statement. This is a summary of what the talk is, so if you're in the wrong place, this is what we think we're going to talk about today. That's the abstract. And our goal is to share our progress in delivering machine learning embedded in the database to extract more information, insights, and to help you make predictions, all in a more automated way wherever possible. We don't want to have this be rocket science. We don't have to have you do too many tedious things. If you want to, if you have nothing else to do and you want to follow me on Twitter, you're welcome to do that. Sometimes I put out links. Sometimes I put out various product information, things that you can get access to. And right now, also, if you go back to my email there, charlie.berger@oracle.com, I've got my away message set up in such a way that when you send something like hi, links or whatever, you'll get my away message that has the links to all the different talks, the OTN website, blogs and tutorials and things like that we have. So you're welcome to do that as well. So what we have for an offering today is kind of getting more and more broadened out and a little bit more complex to talk about. We have the Oracle Machine Learning offering, family of products, if you will, that we used to call Oracle Advanced Analytics, Oracle R Enterprise, Oracle Data Mining, Oracle, we had our various different names, and we said that's just kind of too confusing. It is all machine learning, and so we've just kind of changed our names. You might find in the documentation or on the price list it's still referring to the old names, but from this point forward we've just decided to call ourselves Oracle Machine Learning, and then the subcomponents of that offering are just the Oracle Machine Learning for SQL, the sort of core algorithms that we've been doing for years, the Oracle Machine Learning for R, where we wrap those algorithms and expose them to R and also integrate with R for callouts and extending it. We're offering as a new feature function Oracle Machine Learning for Python that goes into beta this fall and will be on autonomous in the near future, I guess is the way we say, meaning officially or legally within the next 12 months. We also have on the Oracle Autonomous database, we have the Oracle Machine Learning notebooks, which are Zeppelin-based notebooks that are very easy to use. We've been doing a lot of tutorials. There's one more tutorial this afternoon. You're welcome to attend if there's space. Those tutorials have a lot of examples, so you can just really go to the website, log into Autonomous and try out those tutorials. It's a great way to get started. Oracle Data Miner is an extension of SQL Developer, and Oracle Machine, it's drag and drop GUI, it's very easy to use, and then Oracle Machine Learning for Spark, and something new that we're also coming out with Oracle Machine Learning microservices, which allow us to deploy models, sort of like PMML, if you will, but deploy a model as serialized code, put it out on a Docker container with microservices on the Autonomous database instance, and then you can do model management, model deployment. We also add and host model scoring for images, cognitive image analysis, and cognitive text. So that's something you keep an eye out for. So in summary, pictorially, what we're doing is we're moving the algorithms. That's a naive Bayes algorithm. It's kind of a very straightforward algorithm. It just counts. So in the database is extremely good for counting. I did want to ask, how many people here would consider themselves sort of machine learning, data scientist, intermediates, or experts? Any kind of power users here? A few power users. Okay, good, good, good. How many people are here to just kind of learn what's the latest in machine learning from Oracle and kind of think about how they might be able to use it? Okay, so good. So we'll have a mix of some things. Some things will be high level, some things will be deep in the weeds, but we'll try to keep it moving along. So at a high level, what we're doing is we're just moving the algorithms to the database. And we didn't stop there. We added a bunch of algorithms, and we also wrap and expose and integrate those algorithms to other open source languages like R and Python, because not every data scientist speaks SQL, and not every SQL person speaks Python, so you really have to support multiple languages to support all the different various stakeholders in solving these problems. And when you move all the algorithms to the database, you really sort of transform it into much more of a, maybe it's an AI database, maybe it's a thinking kind of database. It really kind of changes everything, because now, especially with AutoML, you could have every variable in the database, and very easily, just by running something like AutoML or the other algorithms, you could make a predicted value for pretty much everything in the database. Your checking account balance, a predicted value. Your age, a predicted value. Your marital status, a predicted value. Same thing, on and on and on. So it really gets kind of interesting when you think about how that works and what the possibilities are, and how you can extend your applications into giving much more insight from your data. So we have a large list of algorithms that are in the database. I was just thinking on the drive over here, the ride over here, that I should probably update this and add in AutoML under the classification and regression categories. So that'll really, and it'll probably go to the top of the list, because if you had a choice, you'd just say, I'll just use AutoML. Why would I do anything else? It's going to run all the other ones in some sort of exhaustive, intelligent way that Nippon will talk about, and it'll be sort of easier. It'll be a lot easier, I would think. So another thing to point out here is that the algorithms are just not your standard Python, R, SAS, SPSS kind of algorithms. The algorithms, although in these new templates, some of the small print I just noticed on this slide is missing, but at the bottom of all the other ones that it says, it also supports partitioning, it supports aggregations, it supports unstructured data, it supports geospatial data. So the database can have all the, has all these features. It can handle unstructured data and so on. The algorithms are implemented inside the database. We're not running R or Python in the database to run these algorithms. We've invented our own algorithms, and those algorithms are capable of ingesting all the different data types. And so they're really able to have complex sort of 360-degree customer view data that includes unstructured data, transactional data, where your car has been traveling in geospatial space or whatever. So they're really kind of interesting. We also have quite a number of statistical functions as well, just basic. How many people knew that we had like a Pearson's correlation coefficient in the database? Or a t-test. Remember that from college? Yeah, I mean, okay, well, he works for Oracle. But there's a lot of functionality in there, and it's been in there for quite a while, and it's very powerful, and it's also becoming sort of ubiquitous, right? All of these algorithms here on the autonomous database, they're all just given away for free, right? They're just part of the whole bundle. And Larry announced how there's always free, always available, the autonomous database. That's including all of this, right? So now you as developers, I think, could conceptually think of saying, well, I can set up a little app that just uploads all my expense reports or somebody's expense reports, run them through AutoML, and maybe finds all the anomalous expense reports. Maybe I want to charge a nickel, per thing or so, but you can really just very easily develop some quite interesting apps these days on the Oracle platform. The algorithms that we're running at their core are usually SQL written as C code, part of the database team written as C code, but exposed as native SQL. So here you just see a simple query doing a statistical comparison, right? I show this as sort of like table stakes. It's like, oh, wow, I didn't know you could do that. And people kind of wrap their brain around that and kind of say, oh, okay, if you can do that, wow, that makes sense. And then we continue on and we say, well, not only that, we could build a classification model. And if you look at the syntax, DBMS, data mining, classification, customer insurance, lifetime value is the table name, and so on. Does that make sense for SQL people? Does this seem like attainable? It kind of makes sense, or it looks a little bit intimidating here? How many people think they could maybe tackle this? Makes sense, at least. A few, right? Most of the people that know SQL that I look at, that I work with, I find it easier for them to evolve from a SQL BI database developer towards adding machine learning skills to their resume and their skill set than it is oftentimes to take a data scientist who knows Python or R very well, but doesn't know the database and doesn't know all the intricacies and the power and the capabilities of the database. Now, we have to kind of meet somewhere in the middle, but I do think it's a short walk from being a database developer or a business intelligence analyst into adding just a little bit of predictive analytics. And when you add in AutoML, it makes it a lot easier. If you're going to do an attribute importance, which is just saying what are the key features, yeah, go ahead. This particular one, it's in the model settings, which I'm not displaying right now. There's a separate little thing that says the model settings that's sort of off screen, and it could be anything. It could be any of the ones that I showed before. The one I stole this from somewhere else, something I was doing was a random forest. You could random forest, support vector machine, whatever, but that's a model settings table, and if you're using the graphical user interface, you would see that, and if you're using AutoML, we'll sort of exhaustively run out, not exhaustively, we'll run them all out, all of them, basically, and do more. Make sure we have enough time to get to all the things here. We have a lot to cover. So attribute importance, that's using a minimum description length. It's finding the key variables, and notice I get 0.2161 for bank funds, and so on. If I want to speak R, how many people here speak R? A few, okay. So if you speak R, you can do the same thing. You're calling the same algorithm, right? You get the same results, 0.2161. If you want to speak Python, how many people speak Python? A few, okay, good. So we're adding the Python, I talked about that. If you're speaking Python, 0.2161, you're speaking your native tongue, whatever language. And as we come out with our notebooks, right now the notebooks that I'll show you speak only SQL, but we're enhancing those, first adding Python, then adding R. Now a team of people in a collaborative fashion, which is what Zeppelin supports, collaboration, can come in and all add their own little paragraphs and collaborate and build a multilingual notebook. So it's really kind of exciting what's going on. So in a total offering, we have the database, we have all the features and functions in there that I described. We have the drag and drop Oracle data miner for sort of citizen data scientists. We have notebooks for notebook users that are currently SQL only, but it's going to the other languages, expanding. We have the Python that is coming soon, very soon. If you're interested in doing beta and you're a current customer of Oracle Advanced Analytics and you want to get access to that, come see us afterwards. R, we talked about that, and so you can, the key I think is not only are we supporting the data scientists, but look over here, the application developers. The application developers and data ones can work together and build more intelligent applications, yeah. Okay, the question is, what do you do about all the data prep? Data prep can be a complicated thing. There's all sorts of stuff that's going on in data prep. Some of the automated data mining, automatic machine learning that we do is handling all that stuff. So we'll normalize the variables, we'll bin the variables. We have something called auto data prep, so I'll get to some of that stuff. You also may just have to clean and scrub the data using other ETL kind of tools. That can get arbitrarily complex, but in terms of getting the data near the algorithms from that point forward, we do a lot of automation for you, and I'll cover that. Some of what the talk is about. So overall, you have data that could be in the autonomous database, you could be on a regular database, on the premise or in the cloud. You have data that's out in the big data lake that with the algorithms I talked briefly about there, and you can join these two different types of data, bring them all together. You can use big data SQL, and you have your choice of different user interfaces and IDEs for doing the work. So it's quite an exciting time. Now, I'm going to kind of go through this real quickly. This is kind of a sales pitchy kind of slide, just talking about the process of doing machine learning, which is kind of iterative, right? And one of the things that we claim, because it's true, is that when you do machine learning, all the data preparation he's talking about, all these different things, if you can kind of do that inside the database and use either Python, R, or SQL to wrangle with the data, assemble, join the data, do the automatic data preparation, build and iterate different models, you can do that all kind of quickly. You can in the database, but when it comes time to doing production, it's already in the database, so it's very easy to just deploy it immediately. If you want to move it from the regular database to a transactional database, we had a talk on that yesterday using REST services to deploy that. It makes for quite a next generation machine learning platform. I refer to what most people do today as sort of legacy machine learning, right? They take the data out of a repository like the Oracle database and they move it over to Python or R and they build some models. These are statistics, 87% of those projects fail. They fail to make it into production because of this kind of outer loop that everyone's doing. So automated machine learning features today, to get to the point of the question in the back, we already do missing value treatments. We replace them with the mean, mode, or user-defined values. We'll bin categorical and numerical values automatically. There's a number of different bin settings. It's all in the documentation, equal width or equal height and different settings there. You can override any one of these things, but if you just press go with auto data prep, we try to guarantee that you'll have a very good experience. If you have categoricals and you have very like, what's your occupation, we'll take it up to 250 different possible values and then bin everything else into other. We also have unstructured data. So if you have, I always joke that if marital status is not single, married, divorce, it's a prenuptial agreement, it's a series of emails, it's a series of tweets. Well, Oracle Text is a feature in the database that will tokenize all that unstructured data, regardless of what, if it's a cloud data type of some sort, give us a vector of terms, and we'll include that as transactional data that goes into the model. We also support aggregations if you want to join things together. Within all the algorithms, they will automatically do any kind of normalization and reverse normalization going in and out of the algorithms that's necessary. We'll do automatic feature selection, we'll do ridge regression, we have a number of different sort of advanced features there. And as I said, everything is very, very fast. We can mine 640 million records, 900 variables, build a generalized linear model in a minute on a properly sized Exadata box with 512 degrees of parallelism. And if you want to deploy that then, it's just scripts, just rerun it, run the whole same script again. Yes, please, in the back. We used to have that in a previous life. The question was, can you use KNN to replace a value, something like that? K nearest neighbors. We used to have that. It was kind of memory hog and kind of a little bit slow. But you can. I have demos and stuff that I show all the time that says I want to use a support vector machine or anything else to make that prediction. I had a person from Turkey that was working on a project that said, Charlie, can you help me? We're trying to do something. We're trying to predict gender. And I go, come on, this is silly. This is for a demo or what's going on? They go, no, no, no. In the data that they had, they found that gender was an extremely important variable for predicting whether or not you're going to do something, right? And so they were using the other variables to make a cut at what the gender was. So yeah, you can nest predictive models, and because it's all part of the same analytical platform, it goes very, very quickly. It's a very productive, platform. So a lot of, and so here's the new AutoML. So AutoML comes in with the Python integration that we're coming out with. That Python integration is coming, quote, in the next 12 months, but it's a lot sooner than that, I guess I'd say. And if you're ready for it on premise, it'll operate just like we do with Oracle R Enterprise. And what the Oracle Machine Learning for Python does, it's a component of the overall offering on premise and then in the autonomous. It integrates with the Python. You can access the existing algorithms using just another language, as I described, or using the Python language. It does that through the transparency layer that kind of does the handshake between the Python syntax, the Python language. Like if I have an aggregation, well, there's an equivalent function in the database called aggregate, right? So it maps Python to equivalent SQL inside the database for massive parallelism and scalability to drive all those parallelized algorithms. And if you want to do a call out to anything else we use, we've been using XProc. We'll change that over to REST API services to make a call out to any kind of Python package. Same way we do with R. Yeah? I'm going to let him talk about the details on that. Yeah. So because the AutoML is sort of a Python-like implementation, it's using Python to do it, the first release vehicle for us was in the Python integration we're doing, so that's where AutoML gets picked up as part of that. The transparency operates just the same way when we do with R, so you can look with Python commands, do functions that are executed inside the database, and you're using our algorithms, using the Python, and you can do the callouts. And if you want to use the AutoML, it's this easy, right? We just have this metric that says, I want to build a model, but I want to build the best model. And under the hood, that means, that's techno speak, if you will, for I'm using AutoML. And so what AutoML does, and I'll not try to steal Nipun's thunder here, so at a very high level, I'm going to have data. It's going to do the automatic model selection in a clever, intelligent way that he'll talk about. It's going to reduce the number of features in a clever, intelligent way that he'll talk about, and then it's going to auto-tune the hyperparameters. So kind of one click, go. And so with that, I'm going to turn it over to Nipun.
Thank you, Charlie. All right, so it's very often the case that data scientists and application developers are interested with some corpus of training data, and they're given a task. The task could be prediction of classification, regression, anomaly detection. And what they're expected to do is to come up with a tuned model which will be very accurate in making predictions for one of the tasks. In order to do that, there are a whole bunch of steps the data scientist needs to do, right? They have to kind of figure out which is the right algorithm. They have to figure out which are the right set of features. They have to figure out what are the right hyperparameters. And this stuff is very, very laborious. It's like very intensive in terms of the amount of time it takes for someone to do. It takes a very long amount of time. And thirdly, it's very resource intensive, which translates to a very high cost, right? Because you have to like use this large corpus of data, go through all the steps, so it takes a lot of compute resources to do it, right? So laborious, time consuming, and very expensive. So what we are doing is we are offering this thing called auto machine learning, which completely obviates the need of all these manual processes. So in one shot, in one step, given a data set, given the task, this AutoML will spit out a tuned model which will be very accurate in making this prediction. There is no human intervention involved. And it's extremely performant, and it's performant because of three things. One, and I will describe each of these boxes, there's a lot of innovation we have in each of these boxes. The algorithms are very unique, which improves the performance. There are a bunch of things which we are doing across the various modules to improve the performance. A good example is what we are referring to over here as the adaptive sampling. Typically what happens is that you have this corpus of training data, which is usually very large, and these algorithms have to go through this entire training data set to come up with, say, like the right feature or the right algorithm. We are able to scan through a very small subset of this training data and yet come up with a model with the same accuracy. So you scan through a very small amount of data, so it saves you the compute resources, and it saves you time without compromising on the performance, without compromising on the score at all, right, or the accuracy. And the third thing in terms of the performance is that our implementation is such, which scales very well, both across nodes and also across cores within a single node. So just to give you like a flavor of what kind of performance improvement we're talking about, so the steps are that there'll be a training data set which has a whole bunch of tuples and the values. So this corpus of training data is sent to this machine learning pipeline, and a machine learning model is generated. At inference time, the user would give a tuple, which is expressed as x1 through x5, and then there'll be a prediction called y. So from these three steps, which is what I'm going to talk about in more detail, feature selection, algorithm selection, and hyperparameter tuning, we are able to significantly cut back on the number of features which the users need to look at, or which the model needs to look at to come up with this prediction by more than half. Usually it's significantly more than half, but I'm just saying like in that order of magnitude. The algorithm selection which we do is over an order of magnitude faster than what someone would do if they had to use an exhaustive search, right? So for the same accuracy, a lot more performant. And then similarly for hyperparameter tuning, that we are able to significantly improve the performance or the score accuracy for the same amount of time. So let me go through each of these three modules and explain what we have done. So for, let's start off with the algorithm selection. So the problem over here is, given a data set and given a task, right? So the task could be classification, regression, anomaly detection. We have to identify which is the best algorithm. Now, what this graph on the right-hand side shows is, and over here we are just showing two tasks, classification and regression, that there isn't a single algorithm which fits or which is the best algorithm for all classes of, say, classification problem or regression. What is interesting is that most of the time, data scientists, they have some preference, or they just have a favorite algorithm, say for classification, and that's what gets used. So if you look at an algorithm like even XGBoost, it is indeed the best model, say for 1/3 of the cases for classification, but for remaining 2/3, it is not the best model. Secondly, what is also very non-intuitive is that complex models, so sometimes people have this notion that yes, neural networks are going to be significantly better than a simple model like linear SVM. That is not the case, right? You can look at many of these linear models. They are indeed better, let's say for 10% of the data sets or 15% of the data sets compared to a model like Keras MLP, right? So one size does not fit all. Complex models are not always better, and the best algorithm is not intuitive, right? So this is kind of the motivation as to why it is important for a data scientist to actually, given a data set, do the due diligence to figure out which is the right or the best algorithm. So what's the technology we have, right? So let me kind of briefly describe. So given a data set, we extract a bunch of characteristics of this data. A good example of the characteristics is, for instance, what's the correlation? What's the cardinality, right? So we extract some very relevant characteristics from this data set, and that is fed into a bunch of microkernels which we have developed, right, for a whole bunch of models. And that's what is shown as the invoking of this prediction models. So we have developed a bunch of microkernels for a whole corpus of models, and we feed this extracted data characteristics into these models. We come up with the score for each of these models, and then we rank it, right? So you have the data set, the training data set. We extract some meta features. We run them through our microkernels in a very efficient way, and then we come up with the score, and we order it. Now, let's look at how does this perform compared to an exhaustive search, right? So what the graph on the left-hand side is showing, on the x-axis are the various data sets. On the y-axis is shown the improvement in the test score. So we're comparing two things, using auto model selection, auto algorithm selection versus exhaustive search, right? So exhaustive search is the best you can do. You can see pretty much across the board for all the data sets, there is very minimal, if at all, loss of accuracy, right? So what this shows is that the auto algorithm selection is as accurate as what you can do in an exhaustive manner. The right-hand graph shows what is a performance improvement. As you can see, the improvement in performance or the speed up over exhaustive search depends on case-by-case basis on the data set, but it ranges anywhere from, say, 10x to like over 100x, right? So that's why I was saying the ballpark is at least an order of magnitude improvement in performance without compromising on the accuracy. The second thing is the feature selection. Now, depending upon the data sets you get, there may be like a varying number of features users may have, but we have seen data sets which have even millions of features. For one of the data sets, I want to make this point that you can significantly cut down on the number of features, which would lead to a significant cut down on the runtime for training the model without compromising on the accuracy at all, right? So you can reduce the feature set, which will reduce your runtime and which will not compromise on the accuracy at all of the system. Now, how do we do that? The way we do this is that given the data set and given the algorithm, right? So we already picked up the algorithm in the previous phase. So we extract meta features from the data, just the way we did in the previous step. And then from the ML algorithms, we use one of the many, so there are a lot of algorithms available for feature selection. So we start off with some feature selection algorithm. We extract the data characteristics, and we try to predict what's the best feature set. So in a way, what we do is that we take a given feature selection algorithm, we come up with the score for the various features, and we figure out that what is a subset of those features which we need to have without compromising the score, right? So we'll reverse order them, or we'll weight them, each of these features, and let's assume that after 4 features we find that as we pick the 5th feature, that is really not making a difference in the accuracy, then we know we'll take the subset of 4. So we keep doing that till we find the right subset. So the termination condition for us is we look at what is the accuracy with all the features, right? Let's assume we are getting an accuracy of 0.92 with all the features. And then we look at what subset of the features is going to give us the same accuracy of 0.92. All right, go ahead. Right. Okay, how about I answer the question a little later, please, right? So our termination condition is to make sure that we are able to identify the smallest subset without compromising on the accuracy at all, right? And we have an opportunity to iterate over multiple algorithms. And that's how we come up with the reduced feature set. So let's look at what is the performance or the accuracy of this, right? So on the left-hand side, the graph shows what is the impact of the test score. Now it's interesting, you would see that in all the cases, in none of the cases there is any compromise of the score. In some cases, by the reduced feature set, we actually have an improvement in the test score. And the reason that is probably happening is because when you feed too many features into some of the models, they actually get confused, or they actually come up with a score which is less accurate, right? So this is very counterintuitive, that by reducing the feature set, by improving the performance, you're actually getting a better score than by having all of them. But never mind that, I would say that we would be as good as having all the features. And then you can see the speed up. The speed up is, I would say, in the ballpark of let's say 50% speed up, which would be like a 2x speed up, right? From just this step alone, which is feature selection. And then the third step is the hyperparameter tuning. Now, this is something which is extremely important from the accuracy standpoint. And what we have seen is that there are a whole bunch of existing algorithms which are around for hyperparameter tuning. But again, just like some of the previous steps, what is very difficult is for a data scientist or for the application developer to figure out which algorithm to use and when. Because there are a whole bunch of characteristics we are looking for. Does it require any input or assistance from the user? How easily does it converge? What is the performance of it and such, right? And our approach, which is what we're calling the auto tuning, is something which provides the best performance, the best accuracy, without any intervention from the user. So the way we do this is, given the data set and the algorithm, we come up with an initial choice of the parameter, right? Let's say for starting off with one parameter. And this initial choice itself is like a fairly intelligent choice. We use that to come up with a model score. Now, when we try to determine whether the next value, right, because we're going to iterate before we converge, the way we come up with the next value is actually based on some prediction or some machine learning itself. So in this step, for instance, we're using machine learning for machine learning to predict what is going to be the next value. And this is one of the ways we actually converge much faster than any of the existing algorithms. Right? So we do that, and we keep like iterating till we converge. And in pretty much all the cases, we have found that we converge much faster just because of the smarter choice of the first choice and the fact that we're able to predict what the next value should be. And we do this thing in parallel, right? So suppose there are like 100 variables you're trying to tune. We don't do them serially. We do it in parallel. And that's one of the reasons our performance on a multi-core or a multi-node system is almost close to linear. So we have done a bunch of things to make these algorithms parallelize so much. One of them is the asynchronous search, right? So when we are looking, or when we are evaluating the value for the various parameters, we are doing it in parallel in an asynchronous manner. So in this example, what we are showing is that we had 32 Spark workers running on about 300 cores, and it scales almost close to linear. Finally, this slide captures the improvement in performance with the auto tuning, right? So improving the score is like a big deal. So far, we were talking about things which are improving performance, the speed, utilizing less resources. This is the case, the improvement in scores over the default value across. And as you can see, it varies anywhere from 5% to 30%. So I would say improvements of about 10 to 20% are fairly common. Last thing, it is extremely simple to use, right? As I was saying, there are just 3 steps. The first step, you have to specify what is a task. Is the task classification? Is the task regression, right? Is that the first step? The second one is when you provided the corpus of the training data set, right? So the second step, you're saying, okay, this is a training data set. Go ahead and do whatever you want. So which is why I said, you just have to give it the task and the training data set. And in third case, it'll do the prediction for you. But this gets much better because this is one programmatic way of doing it. And now what Charlie is going to talk about is how we are integrating this from a UI perspective, so it makes it even simpler.
Thank you. So at some point along the way, I always like to take a picture of the audience and tweet it, and thank you guys for coming, especially this morning. Is that okay with everybody if I take a picture? I always ask, is there any one person that feels uncomfortable and doesn't want to be here, witness protection, anything, raise your hand. Any one person will stop it, okay. So I will take a real quick picture, I'll tweet it, you can see it on Charlie Datamine, but I also say, it helps a lot if you look happy. So I know it's early in the morning, but if you wave high or you look happy or something, it makes it all look a whole lot better. So 3, 2, 1. Thank you. Well, one more here. That looks great, guys. 3, 2, 1. Thank you. All right, I'll tweet that out, Charlie Datamine, if you want to see yourself on a picture. So we're just watching the clock here. I know you got to get going. They're going to throw us out right on the money. So it gets better, we think. Now, as Nipun had said, what we're trying to do is satisfy all the different users. If you're a database developer and you want to use SQL to build an application and do something, or you're a data scientist wants to use Python programmatically, you can build and develop applications. And I actually spend a lot of my time these days working with other application teams who are building and deploying things. And I think we've been doing it very well, very productively, but it'll get even easier with AutoML, because like which algorithm and what settings, you don't have to worry about, just use AutoML. But if you're a citizen data scientist, somebody just wants to click, click, click and get some answers, we're coming out. We also have notebooks that are very easy to use. We have drag and drop GUIs, but this is where we're going. And this will be out, let's say in the next 12 months is all we're really allowed to say, but send me a note or let's talk about that. This will be available on Autonomous in your neighborhood in the not too distant future, I guess I should say. So you'll go to the notebooks, and you'll see some new things, AutoML and models. Models are about model deployment, model monitoring, sort of model management kind of features. And the AutoML is a GUI put on top of Nipin and his team's code that we're productionizing and putting into the Autonomous database. So here I just simply say, I have a table, I have a prediction type, classification, or regression. I have a target field there. Now, if I have to do stratified sampling under the hood, it'll do it automatically. A lot of these things we already have done in the Oracle machine learning offering today, but we do them in pieces, we do them automated, and we're now with all these AutoML features kind of pulling this together even more tightly and crisply. So here you just specify what you want to do, pick a target field, it's going to do the sampling as properly, pick my table, pick my target field. Notice obviously I need to do some stratified sampling or some sort of trick there. It then knows what are the candidate algorithms, just like what Nipin was showing there. So I could decide, no, I don't want to use decision trees. It just doesn't go over well with my management or in this industry or whatever. You can turn off those features. We probably need to set that as a settings table because I wouldn't want to have to do that every single time if I'm in certain industries or so. You can limit the amount of runtime. Let's say you have a big super system and you just want to press go, but you want to say, I don't want to use all that. I just want to do something quick and dirty. You can put a governor on that if you want to. It will go off and do a quick data profiling of the different variables, min, max, standard deviation. These are all statistical functions and such that are available in the database, and we just, of course, use those. So if you have lots and lots of records, we'll scan it all, do the statistics in a massively parallel, process inside the database as any other query would behave. Take a look at the target field, take a look at any variable, kind of drill down and see the details of it. Press go. It's going to launch a number of different in the experiment, it's going to run a number of different models, random forest, generalized linear model, and so on. At the end, you'll see the attribute importance of each variable as it influences the target field. And it will show you the different models, the overall accuracy, area under a curve, and so on. You will have the important features for each different model. You'll have the lift, the ROC, and so on. And when you create a notebook over here, this kind of gets glossed over. Create a notebook will generate all the code that we're doing that's necessary for the notebook, and I can then go in and edit it and take it further. So that's a really nice feature as well, very powerful kind of feature. Look at the ROC curve and so on. These are all things we do today, but they're just kind of getting easier in a thin client up on the Autonomous database. And model deployment now, we're going to that next level where we have the models and we want to put them into production, and we're using these microservices to monitor the models as well. And so I can say a live predict, I want to have a new value come in, I use a REST API or whatever and just make a prediction. Or I can do a batch sort of thing. I can say, well, these are the different models. They're batch predict or live predict. They're in production. I can age them out. I can version the models and check their status. And if there's any kind of drift or monitoring, I can track that. I can set a trigger to rebuild when the drift gets off a certain degree. And I know the problem I have with this is that I'm showing you mock-ups. So you're saying, well, how long does it take to get a mock-up into real code? But it doesn't take that long. It really is. It's well underway. So this is the best. This is the best presentation of the code that I could show today. So it's showing the representation of what we're doing. If you have any further interest in, so that's it. We can take some real quick questions. If you have any further interest in this, what I'd recommend is just Google Oracle Machine Learning. We've done a lot of work to sort of converge all of our different messages, trying to say it's all just one sort of platform, Oracle Machine Learning. We've linked to all the different blogs, all the different demos, the tutorials. It's a really good starting point. You can kind of declare yourself, I'm a data scientist. No, I'm a business analyst. No, I'm an executive. I'm a developer, and it'll kind of take you down certain paths. Again, if you can't remember the URL or how to use Google, you can just send me an email, and my away message will send that to you automatically. I may or may not follow up with a more thoughtful response to that. I do want to also invite you to join us because there are not enough gatherings of people, like-minded people like this, talking about how to exploit all the Oracle various technologies. I and a bunch of others organize a bunch of volunteers, so we're always looking for more volunteers if you want to join us. But we organize these annual gatherings. The next one's going to be out the Santa Clara campus, which is a beautiful campus, and we'll have about 500-600 people out there. You're welcome to join us. We only charge $300, $400, $500 to go. It's a user group. It is not run by Oracle. We formed a separate company. There's separate customers and partners. I and Mark Hornick's in the back over here. We're officially Oracle employee advisors to that, so it's a user group. It's not an Oracle event, and so there's a lot more of a sharing of best practices. How did you do this? How did you work around that? And it's a very good event. We'll have 6 parallel tracks that'll go on for 3 days. So what a lot of people do is they say, hey, I didn't realize there's so much going on here. I should have sent 2 or 3 people from my company. So really consider that. We're also have been doing for the last several months these things called tech casts. So not everybody can kind of go out to California. So what we do is we invite the best and the brightest to come onto stage and show what they can do for how to do something like AutoML, how to do some sort of clever trick using spatial, maybe a combination of machine learning, spatial, and then some sort of map or Oracle Analytics. So if you want to submit something, please just submit. You go to the website and you submit, and we record them. And you can go to the archives and view anything you want. I did a really simple one on analyzing some wine data, and then we viewed the results in Oracle Analytics Cloud. So a lot of fun ones, a lot of great tips and tricks in there. I hope you can join us either for the TechCast or in person. I'm supposed to invite everyone or ask everyone to please fill out the surveys. Please give us great grades like your Uber drivers always ask for. Thank you very much. And again, follow me on Twitter if you want to. Any questions in the remaining 2 or 3 minutes that have not already been asked? All right, we'll take the questions outside. Thank you very much.